Permutation. A selection in which the order of choice is important is called permutation. Permutation has to do with the arrangement of objects, but in an orderly way. Now consider this object which is in a form of alphabet A, B, C. Now, this alphabet A, B, C can be arranged in 6 different ways. We can arrange it as A, B, C. We can also arrange it as A, C, B. It can be arranged as B, A, C. It can also be arranged as B, C, A, C, A, B, and C, B, A. 6 different ways of arranging it. And that's where permutation comes in. Now, the order of arrangement is very important. Although they all contain the same alphabet, the same element in all, but they are different. While the opposite of permutation is combination. Now, combination, the order of arrangement doesn't matter. So everything here are the same. In combination, they're all one. But in permutation, the arrangement matters a lot. And there's a formula that can help us with permutation, which is n permutation arrow is equals to n factorial over n minus arrow factorial, where n is the number of the given objects and arrow is the number of the required objects. Now let's consider an example that will help us to grasp what permutation is all about. Example 1. Given A, B, C, D, and E, in how many ways can you choose 2 alphabets? So the question, we are given A, B, C, D, and E. Now the question is, in how many ways can you choose 2 alphabets from the 5 alphabets over here? Well, you can solve it very fast with the formula. But before we solve it with the formula, let's first of all solve it manually to get the sense out of it. Now, if we do choose 2 alphabets, we can choose AB, that's 1. We can choose AC 2. We can choose BC 3. We can choose BD 4. We can choose DC 5. So there are many ways we can do it. But for it to be orderly, let's assume that the first alphabet is A. Now, A can pair with B, C, D, and E. Now, when A pair with B, become AB. If A pair with C, AC. When A pair with D, AD. When A pair with E, AE. Then, if B is the first alphabet, B can pair with A, C, D, and E. So we have BA, BC, BD, and BE. Then, if C is the first alphabet, C can pair with A, B, D, and E. So it becomes CA, CB, CD, and CE. If D is the first alphabet, D can pair with A, B, C, and E. It becomes DA, DB, DC, and DE. If E is the first alphabet, it can pair with A, B, C, and D. It becomes EA, EB, EC, and ED. Now these are the numbers of ways of choosing 2 alphabets from the 5 alphabets above. Now how many number of ways do we have altogether? We have 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15, 16, 17, 18, 19, and 20. We have 20 ways of choosing 2 alphabets from those 5 alphabets. Now let's proceed to solve with the formula. Remember that we were given A, B, C, D, and E. And we asked to find the number of ways that we can choose 2 alphabets out of this 5 alphabets. Now, the formula that we're going to use is n permutation arrow is equals to n factorial all over n minus arrow factorial, where n is the number of objects given. We are given 5 alphabets, 1, 2, 3, 4, 5, so n is 5. And arrow is equals to the number of objects required. Out of those 5, we need just 2 at a time, so arrow is 2. Hence, 5 permutation 2 will give us 5 factorial all over 5 minus 2 factorial. Now, if we simplify this further, we're going to have 5 factorial all over 5 minus 2 is 3 factorial. And this gives us 5 times 4 times 3 factorial all over 3 factorial. Notice that we'll stop at 3 factorial because we have 3 factorial at the denominator, which we eventually cancel out. And this will give us 5 times 4 is 20. 20 ways. Now, in permutation, there's some concept that we need to know. One of them, which has already had been established, is that n permutation arrow is equals to n factorial all over n minus arrow factorial. Then n permutation n is equals to n factorial all over n minus n factorial. Now this gives us n factorial all over 0 factorial, which is equals to n factorial. The reason for this is because 0 factorial is equals to 1. Then we still need to know that n factorial 0 is equals to n factorial all over n minus 0 factorial. And this gives us n factorial all over n factorial, which is equals to 1. So we need to remember those 0 times. Now let's proceed to example 2. In how many ways can the first, second, and third prize be won by 6 athletes in a race? In this given question, we just need to find the number of n, the number of objects given. So how many athletes are there altogether? There are 6. Then arrow, number of objects required. Now out of the 6, how many of them are we going to give prize to? That theory, we're giving prize to the first, second, and the third possession. And in how many ways can we do this? So it's quite easy. We just go straight to the formula, which is n permutation arrow is equals to n factorial all over n minus arrow factorial. And this gives us 6 factorial all over 6 minus 3 factorial. If we solve this further, we're going to derive at 6 factorial all over 3 factorial, which is equals to 6 times 5 times 4 times 3 factorial. We stop here because the denominator is 3 factorial. At this point, you should be good at solving with factorials. You can just click on this video above and you'll learn more about factorials there. Then 3 factorial will cancel out and we'll be left with 6 times 5 times 4, which is equals to 6 times 5 times 4 is 20, and this gives us 120 ways. And that's the answer. Let's proceed to example 3. There are 11 volumes of a certain dictionary, and a shelf will only hold 7 of them. In how many ways can the books be arranged in the shelf? So we have 11 books, which we are going to arrange in a shelf that can hold just 7. So it's quite easy. The number of given objects is equals to 11. because there are 11 books. But we're going to arrange just 7 of this book at a time. So require 7 objects at a given time. So we'll work with those. N permutation arrow is equals to n factorial all over n minus arrow factorial. And hence 11 permutation 7 will be equals to 11 factorial all over 11 minus 7 factorial. And this is equals to 11 factorial all over 4 factorial. It's equals to 11 times 10 times 9 times 8 times 7 times 6 times 5 times 4 factorial. We can stop here because the denominator is 4 factorial all over 4 factorial. And this implies that 4 factorial will cancel 4 factorial. So we'll be left with 11 times 10 times 9 times 8 times 7 times 6 times 5. If you multiply these numbers with your calculator, you will end up at this value, which is 1,663,200 ways. Next, we're going to talk about permutation involving identical objects. Just click on the link above to access that video. If you have any question on the permutation, please message me directly on WhatsApp. Meanwhile, subscribe to my channel, like and share this video. I will see you in my next video. Bye.